This is homework 3 redo because for some reason my brain wanted to, yeah, regardless. This is the best I could come up with, so since I'm no longer currently in my apartment, I do not have that camera. I left it at the apartment when I was heading to my parents'. So here I am. The best I could do is having my lovely phone in a Teams meeting because I tried to do a connection and then it didn't work and it's all weird, but it won't film it unless it's a full screen. So this is the best I could do. Every once in a while I can scooch back to here so you can see everything, but it's the best I could do. I'm sorry. Alright, so we're changing the CSTR from the previous homework 2, into a PFR. And so with this, basically we're looking at it as 15 CSTRs in series. And so that's why we have n equals 15, and then we were given these constant values. And so with the volume, we're given that is divided by n, as well as UA. And so we have this, and so let's get started. And so we are going to have to define some things. First, we have to define our CA naught, and this is going to be np.full from from n to 0.5. And so basically an np full is kind of like an array, but it shapes it for us. And so we'll take t naught and do a similar np full, and that'll be from n to 350. All right, and then we're gonna do our time end is 3 minutes. All right, and then let's get into, oh, since when does it say generate with AI? That's a new thing that I've never seen that before. All right, so now we're gonna define our PFR, our plug flow reactor, and our two variables are gonna be time and a vector. And so we're gonna have to define our parts of our vectors. So CA is going to be the section of our vector, and then the other half will be our temperature, and so that will be vec, and then we'll do the opposite way. Boom, boom. Oh, nope, I want a colon. Thank you. All right, and then now we have to also put in our K value because that'll change. So our K will be equal to K naught times np.exp to the power of negative ER divided by T. Cool. And so we have to, since there's multiple CSTRs in series, do the plug flow. Basically, we're going to have to do a initial derivative and then the derivatives following. So we're going to do the change of DCA naught. And so this is similar to our previous homework with as far as the equation goes, but we're going to have to change it up a little bit. So we have our flow is equal to CAN minus CA, and this is where it gets funky. So we have to put our first value of that vector, all that divided by V minus our K that we just did, and then our first value times CA first value. All right, and so we'll do the same thing with our dt, but it'll be dt0, and so this will be Q times Tn minus T naught divided by V minus UA divided by our rho times volume times specific heat CP. Multiply that by our T. Oh, no, I didn't hit enter. I was trying to hit shift. Thank you very much. Not. And then minus our cooling water temperature plus our negative HR times K initial times CA initial divided by our rho times CP. Perfect. And so from that, we're just going to copy and paste it, but make some few changes for the varying. So we'll take out the not, and then instead of our CA in, instead of the in, it is going to be our boom -1. So it'll be the value before it minus the value after. Sorry, my ear itches. Up. And then same thing here. Oh, nope, that's not what I wanted. After to do. Still cooling water temperature. Will be K1. Same thing here. Oh, I'm a dummy. I'll fix it in a moment. -1, 1, 1, and 1. And then this was my bad. I'm just gonna go here. Bada boom, bada boom, bada boom. Because I messed it up. It's okay. It's gonna bother me if this is there, so we're just gonna do. Alright. So now we are going to put in our return value after I fix that. Oops, no, there we go. Okay, and then we're going to put our return, which we're going to do NP. Hopefully I spell this right. Concatenate. So basically, it tells you right there, join a sequence of arrays along an existing axis. So this is just allowing us to separate our two. And so we're going to do bum bum bum, we got boom, whoop, boom. And then we have n, boop, r underscore, dca not, and dca, and then comma, np dot r underscore, same thing, dt not, dt. Shift enter. Cool. And so now we're going to have to do our solve IVP. So res is equal to solve underscore IVP of our PFR from 0 to T end. And then we're going to put in our NP, PRF, PFR. There we go. And that'll be our nb.concatenate. And for this one, we will have our CA not and T not. Oh, no, thank you. Finish you, boom. And then we have our method is equal to right out, oh, boom. And then dens underscore output is equal to true, shift enter. What don't you like? What do you not like? Oh, this has to be in dun dun dun, boom, shift enter, and then you also have to get extra stuff. Shift enter. Beautiful. All right. Oh, crunchy neck. So now we're going to start defining our axes and our t-plots, and we're going to have an extra one of our time based off of n. So whichever CSTR it is. Let's go ahead and do our n of t-plot. And so we're going to have 501 because we want, not 5,000, 501 because we want roughly about, we wanted to get to 500 iterations, but they like to start at 0. So we got that, and then our t-plot is going to be our np.linspace, one of our favorite functions of all time. And we're going to have 0 to t end to our n underscore t-plot. Okay, And so we have that, and then we have to define what our CA and our T are going to be, and that is going to be our solution of our solve-IBP. So res.sol of T plot, and then we are going to reshape this so that we can graph it better, 2 to n of T plot. All right, let's go shift enter from there. Cool. So now let's get into graphing. So we're going to want to graph each iteration basically. And so what we're going to do, we're going to add in our fig.make underscore subplots. Rows is equal to 1, columns is equal to 2. And then because we want multiple lines, we're going to do for I in range of n. Oh, sorry. And we'll have fig dot add scatter of x is equal to t plot, y is equal to ca of I and then sorry, is that the one? I think so. That sounds right. Yeah. Okay. And then our name is going to be function no boom of I. And so that'll just put in the I number of each graph. So like CA1, CA2, CA3, all that jazz. And then our row is equal to 1 and our column is equal to 1. And then I'm going to take all of this, I'm going to put it right underneath. And instead of CA, we're going to do T. And then we're going to switch this to T as well. And then this is 2. Okay, and then we are going to put in at the very end, we're going to put in our fig dot update underscore layout. Boom, boom. Oh, what did I do wrong? Is it a comma? No, it is not. Comma I. Oh wait, is it this? There we go. You know what? I'm gonna separate it actually because it kind of is hard to read. So I'm gonna separate that. But shoot. And that means we're gonna take this and make that 1. And then we're gonna remove this. And then copy this. And we'll make it fig 2. And then we'll also copy this, but we'll shift enter there. And then put that back to 1. Is that what it was? That's supposed to be plus, not multiplied. Is that right? Oh. Yes, it was. All right, beautiful. So when we look at this, we see that there's a giant spike coming up, which is pretty understandable because if you think about it for that first one, you have your TA in, your C in, and so that's that's pretty close to one, and then we're gonna have a super quick drop, and then even out towards the end, and then that's not temperature. Oh, sorry, that's why. There we go. And same thing with temperature, where we have this giant temperature change with the cooling water and the reaction, and then it kind of starts to even out towards the end. There we are. That took me way too long to realize that those were, that I had typed those as multiplied, not add. So, all right, there we are.